Hello students, today we are going to start with a new chapter, that is chemical reactions for class 8. Let us understand what do you mean by chemical reaction. Chemical reaction is a change in which elements or compounds react with each other under different conditions to form new products. So, chemical reaction is the change in which elements or compounds react with each other under different conditions to form new products. Now, in this chemical reaction, we have chemical equation which is having two parts, that is reactants and products. So, let us see what we mean by chemical equation. Chemical equation is a representation of chemical reaction using symbols and formulae. Okay, that is in the reactant side as well as the product side. So it is the representation of chemical reactions using symbols and formulae. Now, in chemical reaction, let's take an example. Suppose if we have NaCl. Now, NaCl is a molecule which is held by a chemical bond. Okay, so here we have sodium atom and is combined with the chlorine atom. So here they have the chemical bond. Now in chemical equation there are two parts, that is reactants and products. So reactants are always written to the left hand side and whatever the product that has been obtained is always written to the right hand side. Okay. Now let's take an example. We have Mg plus O2 gives magnesium oxide. So here Mg plus O2 is written to the left hand side and whatever products we have obtained, it is to the right hand side. So when magnesium is burned in presence of oxygen, what we get is magnesium oxide. Okay. Now in this chemical reaction, there is a breaking, the bond between the atoms is destroyed and the atoms are rearranged, okay, in order to get the product. So here the atoms are rearranged and what we obtain is magnesium oxide. Now you all have already studied the atomic theory and the law of conservation of mass. So based on the principles of atomic theory, the number of atoms which are present to the left hand side should always be equal to the number of atoms that is present to the right hand side. At the same time, law of conservation of mass states that matter is neither created nor destroyed. So whatever the mass of the substance is present to the left hand side, it should be equal to the mass that is being present to the right hand side. Is it a balanced equation? Let's check. Here we have 1 Mg, over here it is also 1. Here we have 2 oxygen, here it is 1. So in order to make it as 2, what we are going to do? Yes, we are going to put the number 2. Now this 2 is applicable for Mg also, it is applicable for oxygen also. So oxygen is already balanced, but what about Mg? Mg becomes 2, so here we need to balance it. So now the equation becomes 2Mg, 2O2 gives 2Mg and 2O2. So here we can say that the number of atoms which are present to the left hand side is equal to the number of atoms that are present to the right hand side. Then only when the number of atoms from left and hand side and to the right hand side when they are equal, then only we can say that the equation is balanced. So we have to always check whether the equation is balanced or not. Okay? Characteristics of chemical reactions. Chemical reaction shows any one of the characteristics. For example, evolution of gas, change in state, change in color, change of energy, formation of precipitate. Okay? So first let us study evolution of gas. In certain chemical reactions, a gas is being evolved out. Okay? So the formation of gas is indicated as bubbles, as in the form of bubbles, if the reaction is taking place in a liquid state. So here, the evolution of gas that is in the form of bubbles, we call it as effervescence. Okay? So what do you mean by effervescence? The evolution of gas in the form of bubbles, we call it as effervescence. Okay? So here the gas is being released, okay, evolved out. So let's take an example. We have a zinc metal. When this zinc metal is being treated with dilute HCl, what we are going to get is zinc chloride, and the hydrogen gas will be evolved out. Okay? So when the gas is being evolved out, we have to always mark it with the upward arrow. That is, the gas is being released. So let's check if the equation is balanced. Zinc is 1, here also it is 1, chlorine is 2, but here it is 1. So 2, hydrogen is also balanced. So here when zinc is treated with HCl, we get zinc chloride and hydrogen gases evolved out. Similarly, we can check with Mg. When magnesium is made to react with HCl, what we are going to get is magnesium chloride, okay, that is MgCl2 plus hydrogen gas will be evolved out. So again, we need to balance it. This 2 is applicable for both. Okay, so chlorine is also 2, hydrogen is also 2. Here we can take one more example. For example, if you are using baking soda, okay, the common name is baking soda, chemical name is sodium bicarbonate, or as we can say sodium hydrogen carbonate. So suppose if we take sodium bicarbonate and if it made to react with the acid, for example HCl, it is dilute HCl, what we will get is the salt, that is NaCl plus. Now here this CO3 you need to obtain the gas. So here it will be CO2 and 1. So you will get carbon dioxide gas and 1 oxygen is remaining, here 1 hydrogen and 1 hydrogen. So what you will get? H2O, that is water. Here you are given the another example, that is antacid, which is composed of sodium bicarbonate. Okay, and if the acid is mixed, that is citric acid, that is in the presence of water, a lot of evolution of gas will take place. That is, the bubbles will be formed. Okay, so that is nothing but that is the evolution of gas. Now here again you are given H plus ion. Okay, now acid is nothing but it is a substance which is containing the H plus ions. Okay, so normally acid we write it as H plus, or else if you know the formula you can write the formula of the acid. So here when sodium bicarbonate, when it is treated with the acid, what you are going to get is salt, carbon dioxide gas will get evolved out and water will be formed. Okay, so let's check it practically. The evolution of gas, the first characteristic. So for this I will be using the zinc metal. It is in the test tube, and what I am going to add is dilute hydrochloric acid. So here in this you can observe that the evolution of gas is taking place, that is in the form of bubbles. Can you be able to see the evolution of gas? Okay, so this is the first one. When a metal is treated with the acid, what you get to see is the effervescence. Okay, that is the bubbles. Let's check with the second one. So in this I have taken sodium bicarbonate. The common name is baking soda, and in that I am going to add dilute hydrochloric acid. So when I add the acid in this, see, what you get to see is the effervescence. Okay, so here the carbon dioxide gas is given out. Okay, carbon dioxide gas is released. You can check one more time. See, the evolution of gases taking place. Second one is change in color. In certain chemical reaction, it results in the change in color of reactants. So let's take an example. We have copper carbonate. When copper carbonate is heated, now this copper carbonate is green in color. Okay. So when this copper carbonate is heated, which gas is going to evolve out? Yes, it is carbon dioxide gas. So the carbon dioxide gas will be evolved out, and what you are going to remain with this? Correct. It's copper oxide. So what is this color of copper oxide? It is black in color. Okay. So when copper carbonate is heated, what we get is copper oxide, which is black in color, and carbon dioxide gas will be evolved out. So again, this we will check it practically. Second characteristic, that is change in color. So in this I have taken copper carbonate, which is having green color. Okay, so when I heat this copper carbonate, so what is happening? This green color changes to black in color, wherein you get copper oxide. So which gas is getting released out? That is carbon dioxide gas. So you can observe here, initially I had taken green color and now it has changed to black color. So that is copper oxide. Okay. Third is the formation of precipitate. In certain chemical reactions, a precipitate is formed. Okay. Now, basically, a precipitate is an insoluble solid that is formed during the chemical reactions. So remember, when the precipitate is formed, it is always denoted by the downward arrow. Now, this downward arrow indicates that the precipitate is formed. So let's take an example. We have ferrous sulfate, which is pale green in color. When it is treated with sodium hydroxide, what are we going to get? Yes, we will obtain ferrous hydroxide plus sodium sulfate. Okay. Now this ferrous hydroxide is a precipitate and the color of this precipitate is dirty green. Similarly, let's take one more example. We have ferric chloride. Okay, when this ferric chloride is treated with sodium hydroxide alkali, what we are going to get is ferric hydroxide plus sodium chloride. So let's check if the equation is balanced. Yes, now it is balanced. So this ferric chloride is yellow in color. So when it is being treated with the alkali, here we obtain the precipitate, which is indicated with the downward arrow, and the color of the precipitate is reddish brown. Let's check this experiments practically. Now let us see the formation of precipitate. So in this I have taken ferrous sulfate. So this is solid ferrous sulfate. When I add water, that is distilled water, I will make it in a solution form. So in this, when I add sodium hydroxide, when I add sodium hydroxide, see the color change. What you get to see is the dirty green precipitate. So here already we have studied what do you mean by precipitate. It is an insoluble solid which is formed after the reaction or during the reaction. So here we have obtained green precipitate. Okay. So this is ferrous hydroxide. Similarly, let's check one more example, that is with ferric chloride. Now the color of ferric chloride is yellow. Okay. So in this, I'll add water. So here I have made it in a solution. So in this, when I add sodium hydroxide, so the color is the reddish brown precipitate. So here the precipitate that is observed is reddish brown. Okay. Let us study the fourth one, change in state. In certain chemical reaction, there is the reactants undergo the change in state. Okay. So here we can take an example, that is hydrogen gas, where it combines with the oxygen gas in presence of electric current. What we will get is water. That's correct. Okay. So here the hydrogen and oxygen, these are in the gaseous state, and when it undergoes a change in state, so here this gas is converted into the liquid form. So this is a gas, this is also gas. Okay. So here we can see that this undergoes a change in state. So gaseous converted to liquid. Similarly, we can take one more example, that is a metal when it is treated with acid. Now this metal is in the solid state, acid is in the aqueous form, because acid has been dissolved in the water, so therefore we obtain the dilute acid. So what we will get is magnesium chloride. This is also in the aqueous state, and the hydrogen gas is going to get evolved out. So hydrogen gas, this is in a gaseous state. Okay. Let's check with the third example. Suppose if we use ammonia gas, and when it is treated with the hydrogen chloride gas. So here ammonia, when it combines with the hydrogen chloride gas, what we obtain is ammonium chloride. Now this ammonium chloride, when ammonia is treated with hydrogen chloride gas, it forms a dense white fumes which we call it as ammonium chloride, that is in the solid state. Okay. So let's check this two examples practically. Next, change in state. So here I have taken ammonia solution. So when I heat it, the ammonia gas is released, and when I bring the glass rod that is dipped in HCl, what you get to see is the dense white fumes. So here you can see the fumes. So this is nothing but ammonium chloride. Okay. Similarly, here I have taken magnesium ribbon. Okay, and in that when I add dilute HCl, see here a gas is released. Okay, so magnesium is reacting with the acid and a gas is being released, and what you get to see is the magnesium chloride. So here a gas is being released. Okay. Now let us study the fifth one, energy change. reactions are accompanied by change of energy. So this change of energy is in the form of release or absorption of energy, that is heat energy. So here let's take an example, burning of paper. So obviously burning of paper is a exothermic change wherein the heat energy is given out. So exothermic change is a change in which the heat or light energy is given out. Okay. Now the burning of substance in air at a very high temperature releasing heat and light, we call it as combustion. So here let's take an example. Carbon, when it is treated with oxygen, what we get is carbon dioxide plus heat. So this process is taking place with the evolution of heat. Okay. So here it is undergoing the exothermic change. Similarly, if we take one more example, magnesium ribbon. Okay. So here we can write burning of magnesium ribbon. When magnesium ribbon is burned in presence of oxygen, what we get to see is bright white dazzling light, and afterwards it's formed magnesium oxide. So magnesium, when it combines with oxygen, what we get is magnesium oxide plus heat. We can also say light. Okay. In this one more example, what we can give is respiration. So respiration is also undergoing exothermic change, wherein whatever we exhale out, okay, the warm air is being exhaled out. So it is undergoing the exothermic change. Exothermic change. Now we will study endothermic change. Endothermic change is the change in which the energy is absorbed in the form of heat. So let's take the first example. We have ammonium chloride. So this ammonium chloride, when it is added to water, the process is taking place with the absorption of heat, and what we get is ammonium hydroxide and HCl. Okay, let's check with the second example. I'm sure you all must be aware of photosynthesis. So photosynthesis is also undergoing the endothermic change, in which the green plants take in carbon dioxide, water and the energy in the form of sunlight, wherein in return what we get is glucose and oxygen. So here carbon dioxide, water and energy, that is sunlight. So what we get is glucose plus oxygen. So this is photosynthesis is undergoing the endothermic change. Let's take the third example. Dissolution of sugar. When sugar is added to the water, the endothermic change is taking place. Okay, and what we obtain is a sugar solution. Fourth one is, consider if you take baking soda and in that if you add citric acid, the reaction is taking place and the temperature will be lower. Okay, so the temperature will be decreased and the solution will be cold. Suppose if you place your finger, in that case the bubbles will start forming and the body temperature, leaving your finger cold. So there the absorption of heat is taking place and you can able to feel your finger becomes cold. Okay, so let's check it practically. Now here we'll study change of energy. So here I have taken a magnesium ribbon, and when I burn this magnesium ribbon, what you get to see is bright white dazzling light. So once it burns, what you get to see is a magnesium oxide. Okay, so this is the white powder ash. Now let us check the endothermic change. So here I have taken sugar. So when I add water in this, the sugar will dissolve, and what you will obtain is the sugar solution. So this process is taking place with the absorption of heat, and if you touch from outside, you can feel cold. Okay. So similarly, you can also try this one, that is dissolution of sugar in water at home. So in this, we have studied what do you mean by chemical reaction, chemical equation with the principle, that is law of conservation of mass, and with the atomic theory we have studied how to balance the equation. Again, we have studied the characteristics of chemical reaction, that is the evolution of gas, change in color, change in state, the formation of precipitate and change of color. Thank you.